senior at, he's excited. I'm a rising senior at Nell High School, and so to start off for my starter project for the camp, I built a useless machine, like Oscar said, and basically what it does is it uses a reverse polarity switch, so that when you flip the switch, it reverses the direction of the current within the machine to cause a little lever to pop up, flip the switch back the other way, effectively turning off the machine because that reverse polarity switch is controlling the direction of the current. So useless, but fun to look at. And I wanted to work on that because you get to learn a lot about electrical circuits, and as well as get a lot of practice soldering, which is kind of tedious, but also very important. So for my main project, I built a WALL-E-inspired emotional robot, and basically it's an Arduino that controls about 9 different components that in conjunction make this little emotive robot here. And the reason that I chose this project is because, first of all, the movie WALL-E, it's adorable, but also I was really interested in how you can use really simple and basic functions to create something that would convey human emotions, because I think that's interesting how we can look at this piece of plastic and wood and recognize it. And so now for a demonstration. So right now, WALL-E's in sleep mode, so his eyes are, closed, and when I put my hand close to the ultrasonic sensor, he's gonna turn on basically. Now he's in happy mode. And then I can actually open the serial monitor on the computer and type in a command. So this is his sad face. And this is his heart eyes face. Now it doesn't have as much emotion to it yet, but I'm getting there. And then, so one of the other components that I didn't mention yet is the LCD screen, and the LCD screen can display text. And so I haven't incorporated it into all of the different actions, but for the action that's connected to the ultrasonic sensor, right now it says hi, my name. Or right now it just says my name is WALL-E, and then when he does his little turning on thing, this says hello. I don't know if you can see it, but it's there. And so the way it works is, like I said, there's an Arduino, and then there is, and that's a microcontroller, and that's controlling 2 servos for the eyebrows, and then 2 other servos for a horizontal and vertical head motion. And then as well as there's the ultrasonic sensor, which can detect how close an object is, basically by using sound waves and then calculating the amount of time that it took a sound wave to travel towards an object and then bounce off that object back to the ultrasonic sensor. It uses the known speed of sound to calculate how far away that object is. And then the LCD display, which like I said, can display text. So one of the biggest challenges with this, and then, sorry, I forgot the LED matrices, which are the eyes. So one of the biggest problems with building this robot was how many different components there are. First of all, on a coding aspect, just getting everything to work together, there's a lot of different if statements and a lot of different, you need a lot of different delays so that the motors don't try to do everything at once. I had a lot of trouble because the LCD kept trying to clear itself over and over again when it was trying to display text, so you have to only clear it once before you're displaying text, otherwise it's just going to keep blinking on and off. And then also there was some trouble with the actual configuration of everything, because as you can see, this is a pretty compact robot at the moment, and there is a lot of different components here. So for example, I had to solder my own perf board for both of the LED matrices, and that took quite a bit of time, and that was one of the things that I accidentally shorted, which blew out my USB drive. So, you learn as you go. And another thing that took me literally forever was building my servo mounts, which are the mounts that allow the 2 servos to do the horizontal and vertical motion. Because, first of all, it doesn't come with any instructions, like anywhere online. I literally looked it up, and it was like, you just have to figure out how to build it yourself with pictures, which is really, you know, helpful and easy to figure out how to do, of course. And also, my servos didn't even come, or my mounts didn't even come with all the right components, so I actually had to 3D print and like design some components to add on to the mounts because it didn't come with them. So that was a little bit challenging. I had to get the sizing right, I had to be really precise, and then I also had to file a lot because 3D printers aren't very precise. So that was a pretty big challenge. And then moving forward, I want to add a few different components to my Wally. The first is a wave shield, which will allow him to make noises and sounds when he's doing his little motions. And then I also want to add either a Bluetooth or radio component, which would allow me to control him remotely so he doesn't have to be plugged into the computer. And then lastly, I want to add a tread system that's like RC controlled, or that's a RC is radio controller, but you know what I mean. So you want to add RC treads so that way he can move around and is a lot more mobile, which I think would just add to his general friendliness. And you know, it's like the movie, which is pretty cool. Oh, and then what I learned at BlueStamp, probably my biggest takeaway from BlueStamp was how accessible engineering is. I was honestly amazed at how much I was able to accomplish in such a short amount of time. It was I mean, I didn't have to pay for anything, but I know it was a really small budget. We had to create our own bill of materials, so I know how much everything cost. And also, I literally had zero coding experience, zero building experience, zero any experience. All I had seen was the movie WALL-E, so that was helpful. But, you know, so I was just really amazed at how much I was able to accomplish with all such limited resources, and so, yeah, that was cool. Any questions? Yes, Sam.
I don't know if you know the answer to this, I don't know if you realize you've done it. You call it he. You refer to it like
Yes.
anthropomorphically. Do you know what point you started referring to it as like he with a personality versus it?
Actually, yes. So the thing was that yesterday, this didn't look like this. It was kind of just a blob of wires, and maybe I'll lift it up to show you, because I'm feeling nice. But like, that's like the insides, if you can see that. I don't want to break it. And that was kind of just all over my desk. And I didn't even have this box until Monday. So, yes, because he wasn't really even anything that looked at all like a robot until about 2 days ago. He was just a mess of different components that were all on my desk that worked together, but, you know, didn't really do anything on the emotional aspect. So yeah, probably like yesterday at about midnight. So, Key first.
I think your modifications ideas were good. I think it would be a great product once you add them all. Have you ever thought of how you would commercialize that?
So I haven't necessarily thought about explicitly how to commercialize it, but I did think it'd be really interesting to see if you could incorporate it in a actually like in a health setting. So if you've ever seen the movie Big Hero 6, there's this character called Big Max, which is this robotic friend who helps administer healthcare. And one of his big features is that he's really approachable and friendly, and it makes it really easy for people to trust him. And so I think that might be really fun if you know, I could develop this WALL-E type robot that's emotional, and like you guys all, you know, thought it was really cute when he was sad and happy. And I think that that's a really important response when it comes to being able to trust these you know, inorganic machines. So yeah, like in healthcare, especially with pediatrics, would it be really cool? Asher?
So I know that those little displays for the eyes are pretty intricate. Could you explain a little bit more detail how they work?
Oh yes, I can. So, so basically the LED matrices for the eyes they're 8x8 matrices, and they have, even though there's 64 LEDs, there's only 16 total pins. So 8 pins by 8 pins. And then the way it works is you send well, I mean, I don't personally do it, but the computer sends a flow of, basically a flow of electrons from one pin to another pin, and then where that cross section is the LED that gets turned on. Now, as you can imagine, the problem with this is, let's say if you want to have like an intricate design of pins, if you have all of these different pins turned on, and then all these different pins turned on, you're just going to have a big block of LEDs turned on without any differentiation. So the way that you get around this is the LED actually works by only displaying one row of LEDs at a time. So even though it looks like one static image, it's really just going through an array of LED patterns so quickly that your eyes can't actually detect any sort of difference. So like right now, those eyes aren't actually all LEDs there. It's only happening like one row at a time. You just can't see it because it's happening so quickly. So yeah. Actually, if you take out a phone and you like recorded it, you would be able to slightly see like the flickering through, because your phone camera doesn't pick up as quickly as like your eyes do. So,
So you mentioned that in the future you can see it being used in pediatrics and such. So to accomplish that, would you somehow use some sort of framework or build your own sort of way for it to like have its own like emotions or something?
yeah, so one of the things that I don't know how to do yet, but I think would be really awesome to add is like some kind of facial recognition or video software. So either the robot itself could detect maybe if it's like a kid and they're crying, and you know they can like put on a happy face and like offer them a sticker or something. But also maybe if I could put in a video camera, and so there's somebody who's controlling the robot who they can see the people, but people can't actually see them. So I think both of those might be ways to go about that, where it could be more interactive. Any other questions?
Thank you.
Cool.
Thank you, man.